A translation simply means to move an object. No spinning, no flipping, no making it bigger or smaller, just moving it from one place on the grid to the other. For example, if I wanted to translate this triangle DEF 4 units to the right and 2 units up, it means that I would slide it 1, 2, 3, 4 units to the right and 1, 2 units up. Now, remember how we defined a transformation in the previous video. What do you notice about this figure? What changes and what stays the same? Well, you probably noticed that everything really stays the same. It has the same shape, the same size, and the same orientation. It's set the same way. The only thing is that the location changes. Therefore, in a translation, we could say that the object and the image are congruent. Now, we can write translations as translation vectors, and that's just a fancy way to represent a translation. It's really just a column vector where it has how it moves in the x direction, left or right, at the top, and how it moves up or down or in the y direction at the bottom. So for example, if we had a translation vector like 4, 1, that's just really telling us that our object moves 4 units to the right and 1 unit up. If the translation vector was -3, 2, then that means it moves 3 units to the left and 2 units up. What do you think this translation vector would mean? Well, -1 means that it would move 1 unit to the left, and -4 would mean that it moves 4 units down. Now, there's something interesting that we can observe when translating objects, and I want to see if you can check it out. Now, when I move this object around, when I moved it earlier 4 units right and 2 units up, for example, what did you notice about each of the points? Well, each of the points basically moved by the same translation vector. D moved 4 units right, 2 units up, same with E, and the same with F. So, knowing this can allow us to translate figures without even moving it, without even using a graph. Let's see how that works in an example. In this question, I have a triangle ABC, and I'd like to write down the coordinates of the image of ABC under this translation vector, T. Now, there are a couple of ways that we can think about it. There are a lot of different ways that you can do this. I'm going to start from one of the most obvious, and then you guys can build from there. So the first thing that we need to do is to figure out what this means. Remember that all translation vectors are written in the form x, y. So this is telling us, since it's a +5 in the x entry, then it would be 5 units to the right, because positive is to the right, and -3 in the y direction means 3 units down. So we're going to move the image 5 units to the right and 3 units down. And remember, we had observed before that when we move the image, all the points are moving by the same vector. So that's one way I can do it. I can simply move all of these points in this direction. So starting with A, I'm going to be moving it 1, 2, 3, 4, 5 units to the right, and 1, 2, 3 units down. So my new point A is going to be right here. Let me do the same with C. 1, 2, 3, 4, 5 units to the right, 1, 2, 3 units down. And with B, 1, 2, 3, 4, 5 units right, 1, 2, 3 units down. So those are going to be my new points. This is going to be C prime, this is going to be A prime, and this is going to be B prime. So all I have to do now is to connect the lines to show the image. Let me draw that a little more accurately. So that's here, and that's right here. Okay. I think I'm going to give it a little color here. Let me color it green to kind of, make it look nice. Therefore, that means the coordinates of my image, coordinates of A prime, would be equal to 2, 2. B prime would be equal to 6, 1. And C prime would be equal to 1, 0. All right, 1, 0, x before y. And these would be the coordinates of my image.